Chapter 1. Review of Real Numbers. Natural numbers. The numerals 1, 2, 3, 4 and so on, which are commonly used today to count the objects, are called natural numbers. It is believed that natural numbers have originated in India towards the end of the 8th century. Set of natural numbers is denoted by n and is written as capital N is equal to set of 1, 2, 3, 4 and so on. Whole numbers. The set of natural numbers along with 0 as one more element is called the set of whole numbers. Set of whole numbers is denoted as W and is written as capital W is equal to set of 0, 1, 2, 3, 4 and so on. Even numbers. A natural number is said to be even if it is a multiple of 2 or it is divisible by 2. Example 2, 4, 6, 12, 14, 20, 28, etc. It is a set of even number. Then A is equal to set of x such that x is equal to 2m for every m belongs to capital N. Odd number. A natural number is said to be odd if it is not divisible by 2. Example 1, 3, 5, 7, 17, 19, 23 and so on. Let capital B be the set of odd numbers. Then we can write B as capital B is equal to set of x such that x is equal to 2m minus 1 for every m belongs to capital N. Prime numbers. A natural number is said to be prime if it has only two factors, namely 1 and itself. Example 2, 3, 5, 7, 11, etc. are prime numbers. All prime numbers except 2 are odd numbers, or we can say that 2 is the only even number which is prime also. Composite numbers. A natural number is said to be composite if it has more than two factors. Example 4, 6, 8, 9, etc. are composite numbers. Integers. The union of whole numbers, natural numbers with negative whole numbers makes a huge set of numbers and they are called integers. They are denoted by the letter Z or capital I. It can be represented as capital Z or capital I is equal to set of -3, -2, -1, 0, 1, 2, 3, etc. We can represent the integers on a number line. A number line representing integers moves infinitely on both the directions of 0. Both the positive and negative integers are marked at equal distances as shown below in the figure. Rational numbers. A number which can be expressed as a fraction, that is a upon b, where a and b both are integers and b is not equal to 0, is called a rational number. It is denoted as capital Q is a set of a upon b such that a and b belongs to z and b is not equal to 0. Example 3 upon 5 is a rational number as 3 belongs to capital Z, 5 belongs to capital Z, 5 is not equal to 0, 4 upon 7, minus 4 upon 7, 8 upon 10, 3 upon minus 11 are some examples of rational numbers. Real numbers. A set of numbers which includes all rational numbers as well as irrational numbers is called a set of real numbers. Property 1. Commutative property of addition. If a and b are integers, then a plus b is equal to b plus a. Example, first a is equal to 2, b is equal to 3. Then 2 plus 3 is equal to 3 plus 2. Example 2. A is equal to 6, b is equal to minus 7. 6 plus minus 7 is equal to minus 7 plus 6. Left hand side, 6 plus minus 7 is equal to minus 1. Right hand side, minus 7 plus 6 is equal to minus 1. Now LHS is equal to RHS is equal to minus 1. So a plus b is equal to b plus a. In subtraction, the commutative property does not satisfy. Operations and their properties. We have the four fundamental operations: plus, minus, multiply and divide on numbers. Let us see the properties of different sets of numbers under these operations. Let P be any set of numbers and dot circle represents an operation such that for every A, B, C belongs to P, read the symbol as for all. We denote the properties in the following way. Explanation. If dot circle represents addition, 13 dot circle 4 is equal to 13 plus 4 is equal to 17. If dot circle represents subtraction, 29 dot circle 16 is equal to 29 minus 16 is equal to 13. If dot circle represents multiplication, 15 dot circle 17 is equal to 15 multiply 17 is equal to 255. If dot circle represents division, 135 dot circle 5 is equal to 135 divided by 5 is equal to 27. Thus, the symbol dot circle may be used to represent any of the four fundamental operations on a given set of numbers P. Closure property. If xy belongs to capital P and x dot circle y belongs to capital P, then we say that P is closed under the operation dot circle. Commutative property. If xy belongs to capital P and x dot circle y is equal to y dot circle x, then P is commutative with respect to dot circle. Associative property. If x dot circle y dot circle z is equal to x dot circle y dot circle z, then we say that P is associative with respect to dot circle. Identity element. If xy belongs to capital P and also exists an element z belongs to P and x dot circle z is equal to z dot circle x is equal to x, for every x belongs to capital P, then z is called the identity element in P. Explanation. In a set of rational numbers, the value of z is 0 if dot circle represents addition and 1 is dot circle represent multiplication. Inverse. If x belongs to P and x dash belongs to P and x dot circle x is equal to z is equal to x dash dot circle x, then we say that x is the inverse of x with respect to dot circle in P. Explanation. We note that in sets capital Z and capital Q, the inverse of x is minus x in the operation of addition, and also for sets capital Q and capital R, the inverse of x0 is in the operation of multiplication, that is x dash is equal to 1 upon x dash for every x is not equal to 0. Distributive law. If we define plus and multiply two binary operations over the set P, then we can implement distributive law, which is A into B plus C is equal to A into B plus A into C. We say that multiplication is distributive over addition. Group. A non-empty, that is a set containing at least one element, is called a group under a certain binary operation if following properties are satisfied. 1. Closure property. 2. Associative property. 3. Identity. 4. Inverse. Abelian group. If a group also satisfies the commutative property, then it is called an abelian group or a commutative group. Field. A non-empty set is called a field if it holds the following properties. 1. The set is to be an abelian group with respect to addition. 2. The non-zero elements of the set should form an abelian group with respect to multiplication. 3. Multiplication is to be distributive over addition. Ordered field. A set is called an ordered field if it holds the following properties in addition to the above properties of field. 1. For any two rational numbers a and b, only one of the following relations hold good. First, a is less than b. Second, a is equal to b. Third, a is greater than b. 2. If a, b, c are three rational numbers and if a is greater than b, b is greater than c, then a is greater than c. This is known as transitive property. 3. If a, b, c are three rational numbers and if a is greater than b and c is not equal to 0, then a plus c is greater than b plus c. 4. If a, b, c are three rational numbers and if a greater than b and c is a positive number, then ac is greater than bc. If the set of rational numbers Q has the above four properties in addition to field properties, Q is called an ordered field. Note, the other four properties apply to in, w and z as well. Representation of rational numbers on number line. You have already learnt in your previous classes how to represent rational number on number line. Let us mark the following rational number on the number line: minus 4.2, 1 upon 2, 0, 4, 15 upon 3. You can see from the given figure that these points are marked at different locations: minus 4.2 on left hand side of 0 and 1 upon 2, 4, 15 upon 3, which is equal to 5 on right hand side of the number line.